Huh? You think so? I mean, it's 10 o'clock, you guys. I think it's the makeup of kids. You usually wake up what? No, you usually wake up before 7 or at 7. On the weekends you wake up, but that's not usually. You naturally wake up. You probably naturally wake up around 8, but you decide to slumber and go back to sleep and hibernate. I was there. I remember those days. All right. So now we're going to find the trig values at any angle, which is going to obviously capitalize on the values that you're in the process of rememorizing and reference angles and all that good stuff. So before we get there, though, they give us a point. I'm a visual person when it comes to trig, I gotta say. So -3, -5. You always draw your terminal ray to your point in trig, and you always drop your altitude to which axis? The x. Okay, if you drop your altitude to the y-axis, it's never going to look the way it looks for me. And then I label my side lengths based on the coordinates, so -3, -5. So it's a little funny to label side lengths negatives, but if you do that appropriately, then the negative and positive values of your answers will turn out okay. So find the value of each of the 6 trig functions. Now this is not a Pythagorean triple, right? Because your legs would have to be 3 and 4 and your hypotenuse 5. Now your legs are 3 and 5. So we actually need to do the Pythagorean theorem to find out the hypotenuse. So the hypotenuse is √34. And by the way, even though your legs can be negative based on which direction we're going, your hypotenuse should always be positive. And then we just go through your 6 trig functions. Now, where is theta always as well? So your altitude is always dropped to the x-axis. Where's theta? It's obviously not your right angle, so is it this one or this one? Okay. The one by the origin, we'll say. Right, theta is always at your origin. So opposite over hypotenuse will be -5 over √34. I'm going to bypass rationalizing right now out of laziness. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, which is -5 over -3, which becomes 5/3. So, as I said, by keeping the negative lengths in there, that whole all students take calculus thing takes care of itself. We're in the 3rd quadrant where only tangent is supposed to be positive, and that's just the way it works out. Okie doke. And then for our cosecant, secant and tangent, we're just flipping. Did I say tangent? I meant cotangent. Okay? So the next section, I don't know if you know this vocab word, but quadrantal. When you're not in a quadrant, you're not in the first, you're not in the second, third, or fourth, but you're actually on one of the axes, those are referred to as quadrantal angles. So that's your 0, your 90, your 180, and your 270. Okay? So if you hear that word, that's what that means. This wants us to find the sine and tangent of them. Why not cosine? We'll do all 3. And some of them you have memorized, but my best suggestion is when you're thinking about the quadrantal angles, use the coordinates And the fact that your sine is the y-coordinate, your cosine is the x-coordinate, and that your tangent will be the y-coordinate divided by the x-coordinate. It's just, to me, it's just easier to remember them this way. So this is just what I do. You don't have to. If you already have developed a way and you already know them a different way, because there's a couple ways of thinking about it, feel free. I just will usually refer to the points. So the sine of 0 is the y-coordinate 0, so that's this one we're focusing on. The cosine of 0 is the x-coordinate, so 1. And the tangent of 0 is y divided by x, which is 0. If we move on to B, (90 degrees) is here. Sine is the y-coordinate 1, cosine is the x-coordinate 0, and tangent is 1 divided by 0, undefined. I just thought of a new game. Ask me when the notes are over. It involves a password. That's what you have to tell me so that I remember. I just don't want to record it. But it's going to be a fun new game. We're going to love it. Okay. We're going to make everyone smarter by doing it too. Just a little bit, but still, every little bit counts. All right. In part C, 180, we focus on this. So our sine, I'm not going to write 180, I'm going to write pi because it's easier. Sine of pi is 0. Cosine of pi is -1. Tangent of pi is 0. And then for D, sine is the y-coordinate -1, cosine is the x-coordinate 0, tangent is that divided by 0, undefined. Any questions? Okay. So then, just based on subtle information, you have to be able to read into the fact of what quadrant you're in. So if tangent is negative, that means we're either in 2 or 4, right? And if cosine is positive, that further narrows it down, and we're in the 4th quadrant. Okay, again with the next one, tangent is negative. So again, we're either in 2 or 4. The cosine is positive, so we know we're in quadrant 4 again, but we also have some follow-up to do. How would you handle this? If they told you the tangent of theta, how would you go about finding the cosine and the cosecant? Aiden? That's only if it's in a unit circle, though. And nothing here has implied that you're in the unit circle. Yep. Be more specific. How do I have both of the legs? Right. Right, so they didn't give us a coordinate. Like before they gave us a coordinate, we plotted it. Now they didn't give us a coordinate, but we know where the terminal ray is. We know it's in the 4th quadrant. So we can always drop the altitude, and we can always now label the sides accordingly. So the opposite is -2 over the adjacent is 3. So if we wanted to write the coordinate point now, we could, 3, -2. But Aiden, that still wouldn't go back and help you because we're definitely not in the unit circle, right? So we got to find our hypotenuse. So the hypotenuse is √13. Now we can find the cosine. because that's the adjacent over the hypotenuse. And our cosecant is the reciprocal of sine. So rather than doing opposite over hypotenuse, I'll do hypotenuse over opposite. Okay. So this is where we'll be able to find the sine, cosine, and tangent of any angle. First, we'll master the reference angle. The reference angle is always between 0 and 90. We'll call reference angle R. Between 0 degrees and 90 degrees, or if you're in radians, it's between 0 and pi over 2. If the reference angle is going to be of any help to us, it better be 0, 30, 45, 60, or 90 degrees, because those are the only 5 angles we really know. Or 0, pi over 6, pi over 3, pi over 4, pi over 2, if we're in radians. So it's always between those measures, and it's always the angle made between the terminal ray and the x-axis. Again, the reference angle is never with the y-axis. It's how far away is it from the x-axis. So 345 is in which quadrant? 90 degrees, 180 degrees, 270 degrees, fourth, right? So if this is 345, and here's the angle it's making with the x-axis, the acute angle, if you kept going, the full circle would be 360. So essentially, what's the difference between those? 345 to 360? 15 degrees. So your reference angle equals 15 degrees. Now, they're not asking us to find the sine, cosine, or tangent of 345. So the fact that the reference angle is 15, that's fine. Once we get down here, though, our reference angle should be all one of our key memorized values. What's the reference angle of 5 pi over 6? Pi over 6. That should be a no-brainer. In fact, any of these where they're in pi form, reference angle of pi over 6, reference angle of pi over 3, reference angle of pi over 6. As long as the fractions are simplified, 8/3, which it is, 13/6, which it is, 5/6, which it is, whatever that denominator is, that's going to be your reference angle. As long as, I shouldn't really say that, that's not true. If it's one of our main 5, our pi's over 2, our pi's over 3, our pi's over 6, and our pi's over 4, then it will be. If you had a random, like, I don't know, 5 pi over 8, for example, 5 pi over 8 actually would not have a reference angle of pi over 8. But you'll come across those few and far between, because we just don't talk about pi over 8 angles. So anyway, but also we do want to know what quadrant is this in. What do you think, Bailey? Mitch, help her out. How do you know that? What's your technique? I don't follow. You're right, though. It makes sense. There's just different people. Trig is funny because people build it in different ways, and they're all logical. But we don't all do them the same. Did you know what he was saying, Bailey? No. I'm going to give you hopefully something that's easier. If your denominator is 6, label this 6 pi over 6. If your denominator is 10, label that 10 pi over 10, right? Because then whatever you do, it's going to reduce to pi, which is what that is. But it gives you a frame of reference. So if 6 pi over 6 is there, then 5 pi over 6 is actually just one tick prior to that. Does that make sense? And then not only that, but you can kind of see the difference between 5 pi over 6 to 6 pi over 6 is pi over 6. The reason I'm also talking about what the quadrant is obviously because when we are asked to evaluate sine, cosine, and tangent, whether or not the answer is positive or negative relies on the quadrant that you're in. So you do have to know that. Okay, negative 135, we're going to rotate around backwards. There's negative 90, and then this would be negative 180, but I'm not going to make it there. Negative 135, and this is negative 180. And the difference between them is 45 degrees. Okay. D is different than the rest of them. It's not in degrees. We can do degrees. It's in radians. But it's not in the pi version of radians. So the advice I just gave Bailey doesn't really apply to this because there's no pi in here. So we have to know essentially how many radians in decimal form. So we all know that this is pi, correct? What is pi? What number is that? Pi radians is 3.14. And so if you want another frame of reference, halfway to 3.14 is 1.57. And now it's easy to see that 2.5 is in what quadrant, Mackenzie? The second. There's your reference angle. How far apart are those? .5 to 3.14. What did you say? Nope. If your meal cost $2.50 at McDonald's and you gave them $3.14, what should your change be? 64 cents? Mackenzie? It happens. All right, 580 degrees. Find out what quadrant. We go around 360. So 90, 180, 270, 360. What's the next one? 90 is a coterminal with what? 450. 180 is a coterminal with, what's 450 if you add 90 more? 540, right? If you want to add 90, add 100 and subtract 10. And then add 90 more, so 540 plus 90, like I said, I add 100 to get to 640 and subtract 10, so that's 630. So 580 puts us in Q3, which is how many degrees past the 540? 40 degrees. Without any effort at all, F has a reference angle of pi over 3. We do need to think about the quadrant, though. So, Bailey, what would you label this? Right. So 0, 3 pi over 3, going around another half circle, and you're at 6 pi over 3. Go around another half circle, and this is a coterminal with 9 pi over 3. And so 8 pi over 3 would be one tick before that. And the difference between 8 pi over 3 and 9 pi over 3 is pi over 3. And lastly, negative 13 pi over 6. The reference I already know is pi over 6. The quadrant, I'm going to go around negative. So rather than labeling this 6 pi over 6, I'm going to label it negative 6 pi over 6. So negative 6 pi over 6 is a half circle. Another circle is negative 12 pi over 6. So negative 13 pi over 6 will be one tick past that, which will put us in the fourth quadrant with a reference angle of pi over 6. Okie doke. So the angle, the reference angle, and the quadrant in which it lies are key. Ada. You didn't hear, I was just doing it for practice down here. Because down here, that quadrant that it lands in is going to determine the plus or minus based on all students take calculus. So for the sine of 135, we got to figure out what the reference angle is and where this thing lands. So what quadrant, Olivia? 2. What's your reference angle? .45. So the sine of 135 is going to equal the sine of 45, but is it a plus or minus? All students. So should sine be positive or negative here? Positive, right? So the sine of 135 is going to be equivalent to the positive version of the sine of 45, and our memorized values tell us that that is good. Okay? Cosine of 4 pi over 3. 4 pi over 3 is in what quadrant, first of all? Connor. Third, because this is 3 pi over 3. Good. So 4 pi over 3 is here. So all students take calculus. Should the cosine be plus or minus, Connor? Negative. And it's going to reflect the cosine of the reference angle, which is pi over 3. And the cosine of pi over 3, the cosine of 60, in other words, is 1/2 with a negative out in front. So the answer here is negative 1/2. Good. Cotangent is going to be the reciprocal of the tangent. So if you want to find the tangent first and flip it, you can do that. But let me sketch first. What quadrant will it be in, Marissa? Yep. And is tangent positive or negative there? Negative. So this is going to be equal to the negative cotangent of, what's the reference angle? Pi over 3. So negative something. So like I said, you can find the tangent of pi over 3, which you should know is root 3, right? And then you can reciprocate the root 3 to 1 over root 3. Which would make this negative root 3 over 3 once it's rational. Okie doke. I want you to do D and E on your own. Moment of truth. Trista, what did you get for D? Did anybody get anything different? Sarah, what did you get for E? Did anybody get anything different? Olivia, what did you get? Say it again. Anybody get anything other than those two? Okay, so secant follows cosine. So first of all, what quadrant are we in? Here's 4 pi over 4. Well, negative will go negative. Negative 4 pi over 4. Negative 8 pi over 4. Negative 12 pi over 4. Negative 16 pi over 4. Which puts us very close to negative 17 pi over 4, which is in the fourth quadrant. So cosine should definitely be positive. So just based on that fact, I like the second answer. And then the reference angle is pi over 4. So the cosine of pi over 4 is root 2 over 2. But I have to flip that, right, because this is actually secant. So that would be 2 over root 2, which rationalized will be 2 root 2 over 2, which is just root 2. Sarah, does that make sense? Okay. All right. Suckers, ready for my game?